Alright, if you guys have seen any of my videos before, you've seen the Omniturn CNC lathe working. One of the continuing issues I've had is trying to figure out where I'm getting a slight vibration, which is causing me some headaches, and I think I've tracked that down to the drive system. And what I've decided to do, well, I'll pull that hand box off and get a better shot of that, the current drive system, but what I've decided to do is put in a direct drive system from Omniturn, and I think that's going to alleviate a lot of the problems, so I thought I'd go ahead and document that that process. The other thing I'm going to be doing is putting in a direct drive spindle encoder, so should be able to get rid of this whole apparatus up here on top of the spindle and get that down in the cabinet directly mounted on the motor, which will be really nice too. One less belt to break and a whole lot cleaner of a system. So let me get this palm box off of here and I'll open up the cabinet and show you what's what. Okay, I went and took the entire door off of the front of the machine here. I'm going to be working in there for the next day or so, and just dealing with that door was something I didn't want to do. But this is the drive system. It's a pulley swap type system. You swap the pulleys out to give you different speeds. There's a clutch in here, an entire counter shaft, an entire cast iron apparatus for the counter shaft. All that will be coming out, and the motor, which you can see back here, is just going to go directly up to the spindle where these belts are now going up. So basically we're getting rid of a lot of weight. We're getting rid of 1, 2, 3, 4 different belts, and there's going to be one belt. It's going to be a direct one-to-one drive. It uses a timing type belt too, so that there's no belt slippage. That enables me to use the spindle encoder at the motor instead of up on top of the spindle head like I showed you in the last little clip there. So all this is going to be coming out because I hate doing things halfway. All of the internal hardware for holding, the mounts and all that stuff will come out and be cleaned. The inside of the cabinet will be at least semi-cleaned, and yeah, that's all for now. Okay, this is the kit that NC or Omniturn sends out. The direct drive kit consists of 2 pulleys and the associated hardware, the belt, the direct drive timing belt, kind of cool, has that herringbone pattern, some Z mounts for the motor, some other type of motor mount, don't even know what those are for yet, I'll figure it out, shaft, collar for the mounting the pulleys to the motor. This is the spindle encoder unit right there, along with the mount kit. That's going to be a whole project in and of itself, getting that mounted on the motor. And again, the associated hardware. The kit is about, let's see, the kit was $750. The spindle encoder, the direct mount encoder, was about another $250, I think, something like that. So I think it's one of those things where the the parts aren't all that expensive, but you have to pay for the engineering. Somebody has to figure all this stuff out and put the kit together and stock the kit and so forth and so on. So anyways, I'm just happy to have it. And there are people who have figured out ways to make a direct drive system with V-belts themselves. I don't feel like taking the time to do all that. I'm actually happier to spend the money and have somebody figure it out. And their tech support has been just A1 great. Those guys, they really they just take really good care of you, and they really try to help you out with any trouble you have. So and the guts are now out of the cabinet. Ain't nothing left. Here's the bottom of the spindle, and pretty filthy in here. It's gonna take some cleaning. It doesn't have to be operating room clean, but I do want to get it at least halfway cleaned out. Semi. Yeah, there's the counter shaft with the clutch on it, and the old adjustment bracket. Obviously not all spinning weight, but those things are heavy. So yeah, bad belts. As a former auto mechanic, I know that bad belts can cause noisy and vibraty kinds of problems. The door, this is the motor mounting plate. That's pretty filthy too. It's going to be a lot of fun to clean up. Okay, I got the motor mount cleaned up. That's the mounting plate there. And it's, you know, it's passable. Better than the 1/4 inch of grime that was on it before. Got the inside of the cabinet cleaned up. Again, we don't need to perform surgery in here, but I've always been a proponent of clean machines make better parts. So that part's done. I'm going to have to order some of the isolator bushings, like this one right here. I couldn't find them at McMaster or Granger, any of the usual suspects, but Hardinge had, well, they only have 2 and I need 4, and they're $8 a piece, so they ain't cheap, but they're not horrible expensive either. So I'll get those ordered up. I have all the mounts for the plate cleaned up. I got to look at the directions for the upgrade and kind of figure out where I'm going to go next. So I'll bring you back then. Alright, everything's cleaned up. Well, clean is a relative term. I set the motor mount pad back inside the machine there to measure from the spindle on the motor up to the spindle on the head, just to see, make sure I had the right belt size and everything before I started doing other modifications. I think the next thing I'm going to work on is the pulley on the spindle needs to be modified for the new belt drive gear. Well, I guess it's a pulley too. Man, I can't speak today. But anyways, so I'm going to try to get that pulley off of there, and I guess I'm going to have to make like a little spanner to get this retaining nut off of there, and well, we'll see what I come up with. Alright, so I thought I'd just show real quick what I came up with to get that head nut off of the back of the spindle pulley there. It's not pretty, but it gets the job done. This bottom part is actually an action removal wrench, for bolt action rifles and things like that. And I just made this little attachment up here that I bolted to it, and then I turned down a couple of, I forget what they were, 7/16 by 14, I think, grade 8 bolts. I just turned them down to the diameter of the nut itself, so that, see if I can, kind of hard to see, but oops, those fit in the holes on the nut, and then had plenty of leverage to get the nut off. So, not elegant, but it gets the job done. Okay, the next thing I have to do is get this pulley right there out of the off the spindle so that I can turn it down to size for the new pulley. And I don't really. I guess I could have put some kind of an impact. What's that called? Like a slide hammer on there, but I really didn't want to do that to the headstock. I just don't want to put that kind of impact on the bearings, so I want to pull this off. But it didn't have any a puller with bolts that would work for. They have these tiny little 1032 holes in the pulley there. So I just my solution was, see if I get that to focus. My dirty hands. I just sunk a 1032 screw into the ends of these longer bolts, and we'll see how that works. In retrospect, making those little puller bolts was was a waste of time. As soon as this thing got, I should have used as soon as it started moving, the rest of it just slid right off. So a little bit of wasted time, but better safe than sorry.